So this is a talk about how user experience and data and computer science come together, and it's based on essentially years of trying, failing, learning that we've been doing both in my research group and at Trifacta. And it's a pleasure to be doing this with Giorgio, who comes from the design side of the world. I'm fundamentally a computer scientist, and so part of that learning is to work with lots of good people across different areas. So, part of the framing of the space, this conference and just generally the data space, is that over the last decade, and this is, it's a story we probably all know, there's been a really big expansion in the way that data gets used in organizations, both in terms of who's using data in organizations and why they're doing it. So when we started Trifacta back in 2012, we were sort of at the tail end of the good old-fashioned data warehousing IT era, where data was mostly managed by database administrators and developers in the IT organization, and their job mostly was to mitigate risk. Their job was to keep the bottom line and make sure that reports were generated, that accounts were billed, and so on. And what's happened over the decade, which is really very exciting, is that data has become central to businesses, which means that there's a growing set of business users who are engaging deeply with larger data sets. No longer do we have people who are simply spreadsheet jockeys, but we have people who are really doing agile analysis on big data. And these folks sit in the line of business and typically have a business function, which means that their goal with the data is to maximize value. They're actually trying to generate top-line value for businesses rather than just mitigate the bottom line. So their motivations, their structures, their incentives are very different. They want to be experimental, they want to be fluid, they want to be inventive, and it's a very different mindset than the IT mindset that wants to be careful and governing and deliberate. And the truth is that today we have both of these populations in organizations, and to be a successful organization, you have to facilitate both of these classes of users and their needs. Okay? So it's not a shift from left to right, it's an expansion in both directions, you could say. What's happened, though, is we tend to think of this now as there's this polarization of users. There's your IT folks who are very technical with their green screens, and then there's your business users with their coats and ties who are, trying to make money. And we tend to see them as two opposite poles on our spectrum here. Typically with the technical people wanting to use very powerful, sophisticated, complex tools, and the business people wanting to, have very high-level, simple tools. And this polarization informs, I think, a lot of the way that we think about how to bring companies to market, how to bring products to market, and how to design those products for different user bases. And we'll talk over the course of today about how we think about this space more intelligently, essentially. So really what we're talking about is democratizing data access. Make it easy for more people to get access to more data. And for us at Trifacta, and this predates the company and it predates the goal of building a company, our sense doing research was that in order to get more people using data, we have to start with data wrangling. We have to start with this problem that data is very hard to work with, and that's mostly what people spend their time on. So my colleagues, Sean Kandel and Jeff Hare, led a group of data visualization researchers, kind of worldwide group, writing a research directions paper. This is back in 2011. Research directions in data wrangling, visualizations and transformations for usable and credible data. You can't really work with data till you get past this. And some excerpts from that paper. Sean did this extensive interview study with data analysts in the field long before we started the company, and found that assessment and transformation constitutes the most tedious component of analysts' analytic process. And of course, this much cited line of 80% of the development time and cost coming from people like DJ Patil and others. Okay? And the end result being that domain experts regularly spend more time manipulating data. So those are your data scientists on the left, your IT people, the people with the green screens. They're wasting all their time manipulating data rather than doing analysis. And less technical audience, the business folks, are just simply excluded. All right, so the problem is not on one pole or the other. The problem is spread across the poles, that this friction is keeping talented people from doing what they're best at, and it's keeping people who have other jobs and other talents from even getting in the game. Okay? And fast forward to 2017, just a few weeks ago, Forrester finally came out with their first wave, their first market analysis of data preparation tools. And they talk about how effective time to value for business users dictates which providers of this technology will lead the pack. All right, I'm happy to see Trifacta as the leader in this space. And part of that, I won't say all of it, but part of it is our appreciation of the needs of multiple classes of users. IT and its need for governance, and line of business users and their need for agile and creative use of data. So, the real problem at some level, and I say this with some humility because I'm really a computer scientist and something of a systems guy, but the real problem is not engines, it's not algorithms. The real problem is an interaction problem. For both of those people on the right to work with the data on the left, the thing that stands in their way is the complexity of data wrangling. So what you're seeing here is the example, so this should be the easiest possible example, of the pandas data wrangling library. All right, this is the first example they show you on how you clean up data. It goes on beyond the 53rd line, but it's Python code and it's not simple. I'm teaching pandas to our data science students here at Berkeley this year, and it's kind of mystifying actually. And these are computer science majors at Berkeley, so it's complicated. It's not that it can't be figured out, but it's complicated. And this is kind of the state of the world for many, many people. You write code in a language like Python using a library like pandas, and it is not simple. So there's a real interaction problem if that's your user interface to data. Okay, so what can we do that's better? So let me talk a little bit, take a little bit of a historical view. What pandas does, and it's been done earlier, is that say that data transformation is complicated and it deserves its own little language or library or domain-specific language. Because the tasks and the details of data wrangling are specific, and you don't want to have a full-service sort of programming language. You want one crafted for the task. So this is not a new idea in pandas. This actually goes way back to the 70s. SAS actually had two components when it was first released in the 70s. One was an analytics component, but the first component was called the data step. And the data step was essentially a domain-specific language for data wrangling. And you can still, you do still use this domain-specific language if you're a SAS user. And there's lots of SAS users where this is pretty much what they do. They use the DSL data step for cleaning up data. And the basic flow here is you take data, you have a code editor, you write code in a special language, and you compile that code, you run it on your data, and you get some stuff. Right? And that's kind of the user experience. Okay. So that's okay for technical people, maybe it's not. We'll talk more about that. But there's been an idea, and it goes back to the 80s, that such languages could actually be graphical, and that's a sort of very 80s way of describing it, but that there might be visual metaphors for stringing together the operations in these programs that maybe would be more pleasant than typing at a keyboard. All right, so this is, what's this thing called? LabVIEW, thank you very much. This is the LabVIEW tool, still exists today, and it was, among other things, proposed for use in statistical data analysis. Fast forward about 15 years. This is Informatica circa 2002. This was the oldest screen grab I could find on Internet Archive of Informatica's UI. All right, and it's very much the LabVIEW idea. So the world you're working in now is not a world of code exactly. It's a world of schemas. So you have data representations of schemas underneath this thing, and annotations on those schemas. You can have comments and so on. And then you build these box and arrow data flows, like in LabVIEW. All right. And for each box represents kind of a command in the language. And you double-click on the box, and all the parameters of that command can be selected from tabs and dialog boxes and windows. Okay? And so you can build these data flows by pulling these commands onto a canvas, linking the steps in a data flow, and then parameterizing each command with all of its arguments. Okay? Again, when you're done with this, you have this script. You have data that comes in, you say run, and you get stuff out. And that's the user experience. There are a lot of tools today on the market that provide this user experience. It's been very influential, let's say, all right, and it's very widespread. So some reflection on this is that this user experience is purely schematic. There's no data to be seen here. In fact, this would work if you had no data at all. You could still use this user experience. But if you had lots of interesting data, it also wouldn't take any advantage of that. It doesn't show it to you. It doesn't benefit from it in any way. And the other kind of reflection on this is that the visual encoding of the language, these boxes and data flows, are really purely cosmetic. That is to say, there's a direct mapping from what you would type in a line of code to one of those things. A command is an icon. The parameters of that command are dialog boxes and tabs and so on. So it's visual, sure, but there's really no metaphorical, intuitive benefit to that visualization for authoring. Now, I would say for reading, actually, it is quite a bit better than reading a whole pile of text. So I would argue that it is much more readable because you have the abstraction of the composition of high-level tasks without all the details when you just look at the flow. All right, but there is this long feedback debug cycle also. If data goes in, you've written this whole big script, data comes out, who knows if it's any good. Now you have to think about your whole process holistically to debug it. So I started thinking about this with my students at Berkeley back in 2001. We had a tool called Potter's Wheel that we thought would be a step in the right direction to do better than coding and data flow. And the idea was to have more of a spreadsheet metaphor, but this is really a spreadsheet view of your data while you're crafting transformation scripts. So the idea is that as you're building these scripts, there's a data preview at every stage. So you're always looking at essentially a table or a spreadsheet, a grid of data. But you're basically doing these menu-driven transformations. There's a domain-specific language. Each verb is somewhere in the menu. You pull a verb up, you maybe get a dialog box to fill in with the details, right? And instantly you see what it does to the data. Okay, so you get these immediate feedback. And because you're just crafting a script, redo and undo is straightforward. We just can replay the script without your last step, that's undo, or we can play it with your previous step that you deleted, that's redo. So you're just building a script and you're visualizing the output of script on screen. And this domain-specific language, we tried to design it to make sure that everything you could do in the language would give you this instant feedback. So there's no intermediate steps that leave the data in an unvisualizable state. Okay, so that was pretty interesting. We also had a bunch of intelligent semantics and machine learning algorithms under the covers to figure out what data types were in each of these columns and give you the right transformations for those data types. So it could figure out if a column was a column of numbers or dates or strings and so on. Some reflection on this, it was a direct visual experience of the feedback. So that part of it I think was good. You immediately get feedback. The debugging cycle is much quicker because it's interactive. But still, I would say the visual encoding is purely cosmetic. Now, instead of having icons, we have menu items for commands. And we still have dialog boxes. So really, it didn't help at all with this burden of specification. The user has to know what they want to do, and they have to basically say step by step in this domain-specific language precisely what they want. Right? So I don't think it addressed that problem much. But we saw hints in sort of the 2000s of more intelligent interfaces, like in Google search, where type ahead would sort of figure out what you might want to finish typing before you finish typing it by using context of who you are, what you're typing, and what the data corpus has in it to predict your search terms and preview results. And you can see you get a ranked list of suggestions from Google of what you might mean, and then you could get a preview of the first suggestion before you're even finished typing. All right, so very fluid experience. Can we get something like that for data transformation? So in Sean Candel's thesis work at Stanford, what he was working on was taking the sort of core ideas of Potter's Wheel and extending them to make that authoring task so much more simple. And the basic idea was what we call predictive interaction, where you interact with the data, and I'll show you a picture, an animation of this in a moment. You highlight data or data visualizations, and you immediately get recommendations, kind of like Google search, of what you might want to do to the data. So you get feedback not only on what might happen to the data, but also on what are a set of possible choices that might be relevant to your input. And this worked on sort of browser-sized data sets, which was a bit of a minus of that prototype. So Trifacta implements this in a sort of more robust way now. So I'm going to show you a little just a GIF animation from the Trifacta interface. And what you'll see here is we're going to select some text. We've got to start this thing over. OK, here we go. We're going to select some text, like that last name. And Trifacta is going to make suggestions of what you might want to do. Now, the suggestions might not be right, so we can suggest another last name. And now you get a recommendation that's correct and a preview of the outputs that you might want. When you like it, you say add to recipe, and you're done. Okay? So just a couple of examples of user experience pointing directly, manipulating data, and then you get recommendations of what to do. You never write code yourself. All right? And we call this the guide-decide loop. So the two main features of predictive interaction is all the input as well as the feedback. Not just the feedback, but the input also are lifted into this visual domain. We're no longer dealing with code even metaphorically, all right, except perhaps to read it. Right, to read the description of the steps. Users then engage in this guide-decide loop. They guide the system to things that interest them in the data. They're given choices by an AI algorithm of what they might want to do next, and they decide which of those choices looks right by seeing previews of the outputs. And we annotate the choices with an English description of what they're doing. Okay? So there's really no code here. At most, you're reading some natural language descriptions and you're looking at data visualizations. So we've taken away this burden of specification. So this was very exciting. And as research often is, you get really excited because it solves a really big problem. And then you sort of realize it doesn't solve the problem all the time. It only solves the problem some of the time. But that's OK. It's research, right? We just took a step forward. That's great. So how do we take this research to practice? And we'll talk about that in a second. But just to recap on the evolution, Text editors are kind of the base of all this. Data flow menus and parameter boxes, go back to the days of LabVIEW and ETL tools, and they continue to be used today. Menu-driven domain-specific languages with instant feedback. There's actually products in the market today where that's the innovation, essentially. I would say people are bringing Potter's Wheel to market these days, which kind of warms my heart. But then, taking that a step further with predictive interactions, kind of the experience we were excited about building at Trifacta. So the questions with predictive interaction, though, are these. Did we surface the full space of predictions? No, right? We can offer 3 or 4 recommendations that the user could kind of cycle through to get a sense of what's right. But if those 3 or 4 recommendations aren't what the user needs, what happens, okay? So what are the interaction entry points is also vague. We found as users were using the Wrangler tool, the original research tool, they didn't know what to do with it. And so they would start poking around in the grid to see what would happen, right? The user experience, the entry points are very unclear. It seems like everything could be a way to interact and specify things, but how would I know how to get done what I want to get done? I have to sort of play charades with this tool to figure out, how to get it to do what I want. So the key thing is when this works well, it's awesome. But when it doesn't work well, when prediction fails, then what? Okay? And that was kind of the problem we were faced with at the end of that first phase of research. Okay? And what happens when the prediction fails is whether you're a technical user or a naive user, you're just mad. There's nothing you can do. You can't convince this thing to do what you want. So when we started building Trifacta as a commercial tool, we were well aware of this weakness from our research, and we said, okay, look, there's going to be the 80% of time when predictive interaction works, and it's going to be magic, and our users are going to love us for it. And there's going to be 20% of the time it's not going to work. We need a fail-safe in those cases, where the users can fluidly move to another place to do their explicit transformations. So predictive interaction's magic when it works. That guide to side loop makes code unnecessary, but when it doesn't, it's frustrating. So what is this alternative path to the full power of this domain-specific language that we had built? So first of all, the domain-specific language itself, and this goes back to Potter's Wheel and has been refined in both the Wrangler research and then in Trifacta. The first goal is you want a language that's mathematically elegant. What does that mean? That means that it is sound, complete, and minimal. It can do everything you want. Everything that it does is correct, okay? And it's the smallest number of tokens or words that you need to say anything you could possibly say. If you do that in a language, what you've got is a language that's sort of very elegant and clean. You can optimize it well. It's easy to learn for a technical user. It's sort of a mark of a well-designed mathematical language is that it's got this minimality, this completeness, and that it's closed, that its inputs are of the type of its outputs. So we worked hard on that with Wrangle. And then the other goal was to make sure that for everything you could do in the language, going back to the Potter's Wheel work, that incrementally you could see what was happening as you were building up these steps in this language. So there's always a preview. And then with Trifacta, we worked very hard to make sure that that preview is in context in a nice way. So here you can see source and preview of outputs. And we're highlighting what's happening in the source and showing you what the result is in the output so that the user can visually connect the previous state to the next state in a suggestion in a very intuitive way. So that's all very nice, sort of building blocks. So how do we expose those building blocks to users? Well, step one was we looked at Excel. We said, well, what does Excel do when you can't do things with menus? They have this function interface. People are familiar with that. You type equals. And then if you wanted to pull out last names, you'd say something like left, and then you get some prompts as to what a left command should say. And you say, oh, cell B1, and in cell B1, I'm going to call search. And in search, the text I want to find in column B1 is a comma, and I want to find it once. Okay? And I hit return, and it doesn't work. And then I go, damn it, what did I do wrong? And you go back and you edit, and there's this helpful documentation that says the first field of search was supposed to be the text to find, not the text within. So I got my arguments in the wrong order, okay? So we'll put the comma first and B1 second, and let's see if that worked. Bingo, it worked. Oh, except there's still a comma at the end, so -1. Okay, good. So that's how you do this in Excel, and then you copy paste and you get all your last names. So, all right, there were some nice things there. All right, there's some things that were kind of gross, but there's some nice things too. So in Trifacta, we did something a little bit like that. We have a formula editor. There's a set of verbs and parameters you can choose, and we show them to you in pop-up menus, kind of like Excel does, which is pretty nice. But there's some differences. First of all, the language is more familiar and more, this is the choice of a good language for data wrangling. It's domain specific, so it's focused on what you need to do. So the word extract is in the language, so you don't have to do that crazy left and length and all that stuff. The other thing you'll notice that's different here is in addition to a menu of commands with a little bit of documentation, the parameters to those commands are name : value in the style of Python, which means it doesn't matter what order you type your parameters in, and we also prompt you for which parameters you should type in. So you could put column, before, and so on, and it'll work. And some of the parameters are alternative, so sometimes in a pattern you want to do things before a comma, or on a comma, or after a comma, and those all become options in this parameter space for the command. And this is very much inspired by Python, so this is a kind of Pythonic language. Okay? So some improvements on the function bar in Excel. We try to break down these decisions in a Python style of parameter value pairs. And then the affordances that we did like in Excel, where you have this kind of menu-driven type ahead, okay, with these function names that you can, as you start to enter them, you get a menu, very much like Google search. And parameters, where you get type ahead suggestions in menus, also kind of like Google search. Okay? And the assessment we got from users is, it's still coding, all right? Sorry. You know, we thought this is great. Anybody could learn this. It's a sort of very readable language. Look at that. Drop column candidate status. How hard could that be? Anybody could learn that. At least that's what I thought. I'm a computer science professor. And then you start to show them stuff like this. You know, window with value count and order canned election. This is easy. And people start to say, no, that's not easy. Oh, and I don't have my guy with his ears steaming. But the business people looked at this and said, this is still coding. I'm sorry. All right, and many of those people, if you do user studies of people who use Excel, they stratify into groups. Not everybody spends a lot of time in the function bar, right? So we had kind of that issue too. Okay. So basically, at this point, what I'm going to do is hand off to Giorgio, and he's going to tell you what we did after that.
Thank you. All right. Thank you, Joe. So now, as Joe was saying, we have these two different modes that we introduce. From one side, predictive interaction, from the other, the editor, and they work well, but still, I think the gap between the two is very high. So now you have this very magical way of crafting and starting transformation by selecting in the grid, and you have this very low level script and interface to craft transformation. So the next, I would say, natural step was try to find a way to bridge this gap once again, and basically addressing different issues at once. So first of all, providing an UI that moved a little bit away from code and scripting, as Joe was showing before. So this idea of that you still need to code, maybe we can do something about, and creating a UI on top of the language that is more familiar for the users. So basically moving from a script-oriented UI to, let's say, point-and-click UI that is familiar. And also in doing that, another step is maybe we can do something about the fact that when you have the script, you don't know exactly what the parameters are in advance. So we need maybe to expose those parameters before and let users understand what the transformation is about, and having an easy way to move between them. And of course, this means also making for users easy to find the transformation, maybe again having documentation in place. So all these analysis brought us to introduce a transform builder. So now instead of actually having a single script line that you need to fill in using the code, we broke it down to specific and ad hoc parameters that basically are much more common for users. So you can see like type ahead, menus, kind of intelligent suggestion, and also especially this sort of, again, if you use Excel, you're super familiar with this idea of having in-context information and help. So as I start crafting a formula like here, I can move between a nice UI that provides me some suggestion. I can click those buttons and having list of what is possible, but at the same time is reactive to the place I'm currently in the formula. So there is a much richer interplay between what users can do by inserting text or clicking in the UI. Also, this makes things much easier for users to understand the language itself and to learn the language through this popover. One thing that also we kind of discover while doing this exercise, and that will be more and more prominent in the next kind of iteration I'm going to show you, but has a first seed here, is this idea to not only break the transformation down to the single parameter, creating a UI on top of it, but also start to really understand what's more common and what can we do to make life easier for users. So, for example, in this case, you can replace a text, and you have different options to replace the text that you want to do on a specific pattern in the text, or you wanted to identify two patterns and replace the text between, or two static position. So the point is that this is not in the language itself, is an abstraction and is a structuring of the language that we made because we thought that these pretty much were the was the right way to convey to the users what is possible, and providing sort of shortcuts so they don't have to deal with all the possible configuration at the level of the language, but we provide some sort of, if you want, abstraction on top of this that we believe it's much closer to them and actually reflects what the real intent most of the time is. So these definitely have been proved to be extremely helpful for users to bridge the gap between something that is, again, like predictive interaction almost sounds magical, to something that is very technical, like a script. So now transformations are easy to find, also because we are the ability to search through description, not only the name of the transformation. And as I showed you before, especially complex aspect of the language like formulas and patterns now can be found and can be crafted easily with Builder. And as I mentioned before, we started to introduce these more task-oriented UI and flows rather than bottom-up from the language. But still, I think that even if Builder was a huge improvement, I think that at the same time open up other questions. So the language itself, since Builder is built on top of the language, is still there. And users still need to struggle a little bit with the language in the sense that they need to spend some time and learn the specific syntax, for example, the specific name of the transformation, or the meaning of the parameter within. So also there is no clear affordances for task, in the sense that if users want to do something that is a little bit more higher level, like, remove white space, for example, they need to, let's say, reverse engineering a little bit the transformation and try to find the appropriate verb in our catalog. So, and lastly, of course, the transformation that can be done in Trifacta are presented still in a unique flat list of verbs that users not usually, that somehow can be, let's say, hard for users to parse. So a lot of good stuff introduced, but as usually when we try to improve, new solutions bring up new problems. And so at this point, we try to pause for a second and reflect and doing a little bit more of research and analysis to understand what actually can be an improvement on this direction. And this brought us to considering and to producing a more holistic transformation experience. And let me introduce to it. So first of all, we noticed that not all transformations are the same, right? So as I said before, we have this in Builder, this flat list of verbs and transformation. But actually, if you think about transformations, especially in data wrangling, I think you can easily start to identify very different aspects of transformation. So the first one is that transformation have very different entry points. That means that the place where users start to craft a transformation, or the place where users look for a transformation, or even, let's say, the main object of a transformation can be very different, right? So, for example, here, when you want to drop a column versus when you want to split on commas, I think you can see in the description itself of the transformation, you want to drop a column while split on a comma. The subject there is completely different. From one side, you want to drop a column, and you probably start looking in that direction. While split on commas, the granularity also and the specificity and the nature of the action you want to do is completely different. So a good UX should reflect this and should accommodate according to these differences, or formulas versus something like at the dataset level, like joining. So, for example, just to be clear, if this is the interface, if you want to start from the comma, probably you go and look there. Your focus, your attention starts there from the data you want to work with, versus if you want to work with columns, what you look for is probably a place close to the column where you can start your transformation. Or if you have a more, let's say, high-level task, or you don't really know, but you want to start to search through, you need a place to actually go through all the possibilities in Trifacta. So a second important distinction between transformation is the level of abstraction, in the sense that users and their tasks can be very different in terms of, let's say, granularity of the task. So from one side, users, especially in the beginning, or not extremely technical users, they can reason through more higher level tasks, like, oh, I know there's something wrong in my data. I want to clean the data set. Or I know that in this column there are a lot of different patterns. I want to explore these patterns. So it's not a really specific transformation you look for. It's more like a higher level task. So at the opposite side, sometimes you perfectly know what you want to do, and your task is extremely specific, so like replace quotes. So again, this diversity of abstraction needs and demands a different UI for these tasks. So how to bridge these gaps, right? This is, I think, particularly like this. So this is an example of a task the user can do. So they want to filter values that contains a specific text in it. And in this slide, you can see how they could do this in the different UI we provided. So first, as we've seen with the editor, you needed to find the transformation in craft and still going through the syntax of the transformation. With Builder, things were a little bit easier. We broke down, but still, of course, like in cases like this, the specific language is very far from the thing on the top that you wanted to do. So to be honest, what people really want, probably something like this, right? So, I want to, basically, I want to tell you two things about this. One is the columns I want to apply the transformation. The other one is the piece of the text. So we're really trying to go in that direction. And I'm here introducing task. So by task, we mean this transformation that can reflect actually what the users want to do. So tasks can be very familiar to the user in terms of language, like we have seen before. I want to filter, I want to remove white space, I want to combine these two columns. Are frequently used are the UI to accomplish task reflects the task itself and not the language. And they help a lot to kind of structuring and grouping transformation and provide a sort of a clear ontology of what your transformation is, a space is in Trifacta. So let me show you what we mean. So it would be, going back to the example before, now if I want to do something like a filter, now again, filter definitely from a column I can see, and this can be an example of action, this time no more driven by the language, but by driven, let's say, by what users want to do in a very, very, say, natural language and common language for the user. Like in this case, this ontology that I was talking before, so we start to, create these categories that hopefully will continue to improve. But the idea is like you provide a step-by-step access to the users, so they don't have to deal again with that old flat list of transformation. But it's like, oh yeah, I want to probably filter. Oh, and now have this option on filtering. And also, when I select that, you have still all the benefit that we've seen before, the preview we had, but at the same time, the UI to craft and edit transformation is now extremely much closer to what the idea of the task was. And the good thing of this approach of having tasks is like it's extremely scalable, can be consistent across the whole product, and we can iterate over that and finding either the bad description or the best task for the specific actions. Again, you can have a place to search through what you are looking for. In this case, task. They have the advantages of being, can be a different level of specification. So you can have tasks that sort of things that we know users won't probably do, but at the same time we can still expose like core aspect of the language, like in this case, formulas. So again, what I'm going to is this idea that you don't need necessarily to pick up a specific level of abstraction in this case, or level of granularity with this approach. Also, the next step is kind of going back to the idea of predictive interaction and see if we can apply this on tasks. So it would be amazing if not only have this space of tasks, but also I can somehow, the tool itself can tell me what a good task is for my case. So this is sort of more kind of still on under development idea, but the idea here is that you can imagine as soon as I open the tool, I already have these suggestions you can see on the right that tells me, provide me those kind of entry points very easy for me. So I never use Trifacta, or maybe I don't have a clear idea of data or what data wrangling is in this case, or even I do, even if I do, for example, I can, just one click and can create a join or a union simply because we can detect that that's meaningful for your task. So I think the time is now. So try to conclude. So we started this talk, Joe started this talk talking about this polarization between these users. And what I hope was kind of could emerge from the different iteration we had at Trifacta. We gradually, when you start to better understand these differences between these users, what they really want to do, or their task, their kind of background, their skill, what happens is that this polarization metaphor actually starts to fail, or better, a polarization that consider these two as opposite parts of the same system, it ignores all the differences between these two users. So a polarization, I think, is a very limited approach to the space we are dealing in with data wrangling. And through our iteration, I think that we we pretty much realized that we need a different approach, a different UX philosophy that not only acknowledge the differences, but in a way leverages them. And by that I mean not only because at the level of, let's say, personas between these two groups of users, but actually a design that can leverage all the different complexities of these users, as we can see here. So users that have different tasks, different abstraction levels for what they want to do, different affordances. And so instead of actually promoting an idea of two divergent space, actually we should focus on more leveraging the different aspect that from one side these two kind of extreme shares and the difference that they have. Thank you. You can find Trifacta at booth A23. Do we have time for questions now? Okay, so please find us if you have any questions, or probably be around for a while here. Thank you.